Hi everyone, this is Mrs. Pagan, and in today's lesson we will be simplifying radicals. So let's go ahead and get started on at least terminology. Alright, so what we have right now is a radical. It's square root of 16. The whole thing is a radical. We have the radical sign, which is the square root, is what we tend to call it. And then we have the radicand, which is 16 inside. And then when we end up getting an answer, the square root, the answer ends up being our square root. Okay, so couple terminology, key vocabulary words. If you forget what I'm talking about, just kind of go back to this figure that's right here. All right. We're going to be talking about the two properties of square roots. We're going to start off easy with one simplifying, and then we're going to kind of go into multiplying and the quotient property of square roots. Okay, so bear with me on what those really mean. Okay, let's go ahead and get started. We're going to talk about perfect squares. So I know that some of you already know what your perfect squares are. For example, we know that square root of 1 is a perfect square. It equals 1. We know that square root of 4 is a perfect square. It equals 2. We know that square root of 9 equals 3. Square root of 16 equals 4. We have square root of 25. That equals 5. Square root of 36 equals 6. Okay, now go ahead and give me a couple examples yourself, and I'll check those out in class. All right. So first, let's start with simplifying radicals. What we tend to do is try to figure out what the multiples of 24 are. So I'm going to go ahead and start with the square root. I know that 6 times 4 is 24. And then I'm going to go further, and I know that 6 can be broken down to 3 times 2, and 4 can be broken down to 2 times 2. Now, a square root means pairs can come out. So I'm going to go ahead and circle all my pairs. I have 2 2's, so a 2 will come outside. So that results in that. And then since the other 3 and the 2 don't have pairs, they're going to stay inside the radical, and that is going to be 6. So that's our final answer. All right, let's go further. Now, we know that if we have 2 radicals being multiplied, then we can go ahead and multiply the radicand. Okay, so I'm going to just go ahead and do 6 times 15. We can just kind of put them together. Now, because I'm in the process of simplifying, I don't want to really know what 6 times 15 is. But what I do want to know is how can I break down the 6 more? Well, we know that 2 times 3 can break that down more. We also know that 15 is the same thing as 3 times 5. Now, I'm going to look for my pairs because I know that I can't break down 2, 3, and 5 any further. And I see a pair of 3's. So the 3 is going to come on the outside, and 2 times 5 will be multiplied as 10, and that will be my final answer. All right. Now, let's look at example number 3 because it's a little bit different. There's actually a number on the outside already. So what we're going to do is keep that number on the outside, but with the radicals, we're going to combine them, and we're going to say, okay, well, that's 3 times 3. So we're putting these two radicals together. Well, I know that I can't break down 3 any more than that, but I do see a pair, so here's what happens. The 4 that's on the outside will stay on the outside, and the 3 now will come outside as well. Now, notice there's nothing left inside the radical, so there's no reason for me to write anything. Well, then I don't want to leave 4 times 3 because I know what that equals. So our final answer is going to be 12. 4 times 3 is 12. All right. Let's go on to number 4. Okay. Once again, we have a 2 on the outside. We're going to keep that 2 on the outside, but we're going to go ahead and combine these 2 together under the same square root. So we have 3 times 6. Oh, excuse me. All right. Now, we have these 2. Let me just kind of go back a little bit because it did shift my... Let's see if I can. There we go. All right. So we have our 6 there. Now, I don't want to multiply these again, so I'm going to break them down further. 3 doesn't break down any more than that, but 6 does. So we have 2 times 3. And I can see that I have a pair of 3. So here's one, here's the other. Connect them. okay? So that means a 3 is going to come outside. So we already have a 2. That's this one right here. We are going to have a 3 come outside because of those two. And the other 2, this one has to stay inside because it doesn't have a pair for it to come out with. So we have 2 times 3 is 6, square root of 2. That's our final answer. All right, let's look at example number 5. We only have 4 more examples to go over. Now, example number 5 is a division. But one of the division properties up top says if you have a fraction inside of a square root, you can go ahead and split it up. So square root of 49 divided by the square root of 16 is ultimately the same thing. Okay? So sometimes I like to just kind of do my work on the side. So I'm going to just go ahead and do square root of 49. Well, I know that's 7 times 7. That's awesome because I already see a pair right there. So 7 times 7 is a pair. So a 7 comes out, and there's nothing left inside the radical, so there's no need for me to write it. So I know square root of 49 is 7 on top. And I'm going to do the same work with square root of 16. I'm just going to do my work here so it doesn't get so messy up top. And I have 4 times 4 is 16, so that's a pair right there. So a 4 comes out, so it's 7 over 4. Now, I always ask myself, can I simplify this further? And the answer to that is no, so therefore that's my final answer. All right, let's go ahead and now try number 6, 7, and 8. Go ahead and try that on your own, please. And once you are done, we will check those 3 problems in class. Great work today. That's pretty much all we had to talk about with radicals. We'll do more of these examples in class. Awesome job. Woohoo!